Hello, this is Jim Harris of TES Clean Air Systems, and I'm here to tell you a little bit about the application of airborne molecular contamination filters on fan filters. A lot of information here, so we'll jump right in. First thing would be how an airborne molecular contamination filter works, and basically why somebody would use one in the first place. The reason is because even parts per billion level contamination, what they call gas phase contamination, can cause problems with semiconductor processes. The finer the processes get, the smaller amount of a gas phase contaminant will cause a problem. And basically the way these filters work is that they're not mechanically straining out these species, they're actually adsorbing them as the air is in residence with the media. So it's very important in the application of these filters that they're not run at too high a flow rate. Flow rate being higher than the manufacturer's specification, which is typically 100 feet per minute, similar to air filters. And if you increase the flux rate, the flow rate per unit area through the media, it will become less effective because it doesn't have the residence time to do the job that it's supposed to do. So, and you'll see why that's important as we get into this. Okay, AMC filtration and FFUs, let's take a look. This is a slide here showing an American air filter, Megacell PTFE filter, and even though it's a little bit hard to see here, this is the pressure drop curve. That's the 100 feet per minute level right there, and this is showing that if you go straight across, it's 0.48 inches at 100 feet per minute, and we'll get to why that's important in a second. Just a quick tech note, you're going to see the terms 100 feet per minute and 90 feet per minute used interchangeably. The reason for that is that at 100 feet per minute, that's the actual spec of air coming out of the filter. But the filters don't give 100% coverage on the filter itself because of the glue and the frame around the edge. So it takes about 100 feet per minute to have out of the filter to have 90 feet per minute in the application. So depending on who's doing the writing, you'll see 190 feet per minute used interchangeably, and so I'll try and point that out here as we go to make sure that's not confusing. And so the first thing is, when you're using a airborne molecular contamination filter in a fan filter, from the fan filter standpoint, it's a pre-filter like any other pre-filter, and it represents a pressure drop to the system that was not there before you put the pre-filter on. Typically fan filters are specified with about 20% reserve for filter loading, but not much more than that because customers typically don't want to pay for a lot more fan than they're going to use. When you add an AMC filter to a system, how much pressure drop are you adding? So here's a couple of examples. Here's a Camfill Gigaplete. This is a popular filter in the marketplace, and basically, even though it's a little bit hard to see, I'll zoom in here. What I did was I just went to the pressure drop at 100 feet per minute right here, and then went across to the pressure drop, and it's 60 pascals, so about a quarter of an inch. So there's your quarter of an inch right there. So there's one example. Now that's on the low end of the spectrum. A lot of them are significantly more than pressure drop out there. There's another example, a Donaldson BSM broad spectrum max lithography filter, and basically if you go right to their pressure drop curve right here, and again I apologize, it's hard to see there, but I've made a little note to make it easier. It's 0.8 inch pressure drop at 100 feet per minute, so roughly double what the filter or the fan filter was originally intended, specified to be used for. And so basically, when you add an AMC filter, what's that going to do to the flow? Following here is a EBM Pabst 220 millimeter wheel, which is the most typical ones used in the Airflow Tech fan filters. And again, a little small here, but all I did was just run some curves at, here's the pressure drop, here's the area where you've got 0.48 inches, you got about 425 CFM, but if you add 2/10, like you would with the Camfill Gigaplete, drops it down to 300 CFM, and if you add 8/10, it drops it clear down to 125 CFM. So the answer is you're losing between 30 to 70% of the flow when you've only got 20% reserve. So hopefully that's pretty obvious from an engineering standpoint that you can't just throw a fan filter, you can't just throw an AMC filter on a fan filter and expect it to work. And there's another issue coming up we'll get into. All right, so anyways, I already made that point there. You just can't throw it on an existing FFU. There's an additional issue with retrofitting an AMC filter, and keep in mind we want to keep it to 100 feet per minute, which is the typical for both the two examples I had there, the Camfield Gigaplete and the Donaldson BSM Max, and really most of them out there. You're looking at 100 feet per minute through the fan filter, through the AMC filter, meaning that the surface area of the AMC filter needs to be very similar to the surface area of the fan filter. Here's an example right here of it's actually a 2x4 fan filter. You can see the entire top is stacked with these AMC filters to give you the give you the design flow that you need. A lot of single fan designs out there, popular low-priced, market-priced fan filters use a single fan, and they have a single 12x24 fan filter here. So without major retrofit, we see people trying to just take an airborne molecular contamination filter and sit it directly on the top here, which would give you 350 feet per minute inlet velocity, 3.5 times what's acceptable, and basically it takes the AMC filter and makes it work very poorly, not remotely what you thought you paid for, and it'll also be used up in no time flat. Good practices and rules of thumb for well-designed AMC filters. One is that there needs to be a mixing plenum, meaning an area between the fans and the bottom of the AMC filter. If the AMC filter sits too close to the fan inlet, air will be selectively drugged through that part of the AMC filter, again, not giving you the life that you expected. Manufacturers ask for 8 inches of a mixing plenum. Oftentimes in applications we just don't have the room to give it that. We've made successful designs that had mixing plenums as short as 3 inches. Here's a fan filter that's actually one that is in manufacture today, and you can see how tall the air mixing plenum is, and this entire top area here has a large AMC filter in it that's actually, as you can see, roughly the same size as the fan filter itself. So that's a good design, and that one works well. For servicing the AMC filters, it's a lot of times they come with handles on them. They're fairly large and fairly tall, sometimes a little heavy. So here's an example of side-by-side airborne molecular contamination filters with handles on them. Here's the air mixing plenum. And just a side note, this particular product here has a PTFE filter at the bottom, and then also powers a Simco-ion interface module, and underneath this right here is the ionizer itself. So that all comes integral to the fan filter, and that's a whole nother discussion, but just while the picture's here, I thought I'd point that out. So anyways, if you have an application where you need or feel you need an AMC filter, we need one of two things. We either need your spec or your customer's spec of whose filter to use, and then we can size it into the application, or if you give us the concentration of the species, then and what you want it knocked down to, we'll deliver you a solution, and we'll go out and get a couple vendors to bid on it, and look at all the parameters and come up with the best solution there. And so basically this is a sort of thing you'll end up with as part of the proposal. A filter efficiency lifetime curve. You'll tell us what you want to remove, and then here's all the flow rate and information. Standard, again, the 90 feet per minute being called out here. So this curve right here shows that here's your filter life in years versus the efficiency. Typically, in high-end AMC filtration, it starts at the surface life of the AMC filter starts at right around 100%, as you can see here at the far left of the slide, and then it goes over time to about 1.7 years. It's down to 90%. Now, there's nothing magic about 90%. You don't have to change the filter at 90, but that's kind of a de facto standard. When it's not removing as much as 90% of the species that you're worried about, that's typically when the filters are replaced. So anyways, that's a little discussion on AMC fan filters. Hope it's been informative and worth your time. If you have any questions, need a quote or whatever, give me a call, 510-656-5333, or to email to jim@tessinc.com. Again, I hope this has been worth your while, and thank you very much for your time.